You have a fair 100-sided dice and you roll it 3 times. What's the expected value of the smallest roll?
This problem is a great excuse to show you a useful trick in probability. First, let's see what the problem is asking. We have 3 100-sided dice, and we're going to roll them and record what number is the minimum. So for instance, if these were our rolls, this is what we would write down. And if you think about it, of the million possible rolls we could get, there's only one where we would write down a minimum of 100. But actually there are quite a lot where our minimum would be 1. In fact, it doesn't matter what the other numbers are here, so we get thousands and thousands of times we're going to be writing down the number 1. The original problem said if you write down all million of these possibilities, what would be the average of those numbers? There are lots of approaches to do it, but I want to take the straightforward one, which is saying, well, let's find the probability that the minimum is some number. Like, what would be the probability that the minimum was 40? That's actually a pretty hard problem combinatorially, at least it's a little bit messy. But there's a much easier problem, and I'm going to show how to connect it to the harder problem. The easier problem just changed that equal sign to an inequality and says, what's the probability that the minimum is greater than 40? Well, if the minimum is greater than 40, then all 3 numbers have to be greater than 40. And if that's the case, then the minimum would be greater than 40. And so this is just equivalent to counting this thing down here. And we know that there's a 60% chance that any individual number is going to be bigger than 40. So because those events are independent, we just get this nice formula for the probability of something being greater than 40. How do we connect this to the harder problem though? Well, that's the key idea that I wanted to share. And it's just that if you want to know the probability that something is equal to 40, we'll find the probability it's greater than 39 and subtract off the probability it's bigger than 40. The only thing that's left is going to be the things where it's exactly 40. And by a completely analogous thing, right, both of these problems are easy because they were the easy problem. So if you want to see what it would look like in general, it looks something like this. And then the full answer to the original video would be this sum down here where I guess we go from 1 to 100. I think it's around 25.5. But I'd love to hear your other ideas of how to solve this problem.